class, and we now do it out by the lake. So it's a wonderful set. So we are inviting everyone to come tomorrow morning at 6 a.m. for the final session. It's very, you can join in. It's for all levels, from total beginner to people who have done yoga before. So that's the first thing. It's a wonderful part of the workshop. So let's do our goals for the day. Our meetings. Okay, we are in day 3. So the goal for yesterday was start nuts and bolts, and the goal for today is continue nuts and bolts, because our breakout sessions today will be delving even deeper into the methodologies that we were discussing in the round robin yesterday. So that will be, and they will be in, rather than traveling by team, which is what we did with the round robin. Today we break into our it's in subject matter teams. So that's why the crop, climate, and IT is in for a while, go together, and then the economics team also meets. The economic participants from each of the regional teams goes for the economics group. Are there any other announcements or anything to start the day before we start our plenary talk? Great. So what we thought we would start out with, before we go to the 2 slides from everyone on with the check-in and reactions from yesterday, and lessons learned from yesterday, is that we would ask Cheryl to give a presentation of the IT tools and databases. We've been talking about them and mentioning them. We thought it would be good to start the day with an overview of the AgMIP IT system. Cheryl, thank you so much.
Of how we do these and what it means to make AgMIP data available to the modeling community, how we express ownership of the data, what requirements we have for documentation of data, and what infrastructure we have for providing that data and making it available.
I have taken from the.
Also at that meeting, what they chose was to adopt the Open Database Commons Attribution License for AgMIP data. And this doesn't mean that all AgMIP data has to be open. You know, originally we had hoped that if it's AgMIP, it's open and available to the whole world. But we've quickly come to realize that that is not really feasible. There's a lot of data that we want to use in AgMIP exercises that is not completely open. But the data that we do share with the world, that you give us permission, we upload the data, we harmonize it, we make it available, we will use this Open Database Commons license. Okay, so AgMIP IT products and data products, we have, there's a whole realm of data services and products that we will be dealing with in AgMIP, but this is what we're currently focusing on. We have websites, we have some of the tools we've been working on, and some of the databases that we're working on. So for the websites, I'm sure you've all by now seen the agmip.org website. It's just been renovated, and the new public site is available. If you haven't been there, please check it out. This is being maintained mostly at Columbia University, also at University of Florida. We have a new web content manager that's been hired at Columbia University to keep that content fresh and up to date. We also have go to document their systems, document the models, document data, methods. We have wikis set up. There's I'll demo this later today. We have a session, I think it's at 4:30, where we'll demo the research site and show you what's available, show you where the, we have research sites set up for each of the South Asia teams. So you have your own wiki, you have your own discussion forum, and you have a place to upload and download files. So if you're interested, if you want to use that, and I encourage everybody to take a look at it and think about how you might use that within your team communication. But we'll be demoing that later today. We also have what we're calling the AgMIP toolshed at tools.agmip.org. This is very preliminary. We actually only have one tool posted there currently. But that's where all of the applications that we're developing will be made available to people. And if you've got tools and applications that you're developing that would make it easier, that you think other people in the modeling community could use, we'll be willing to make those available there. We've been collaborating with CCAPS on a model documentation wiki at www.agmip.org. This is very preliminary. It's in the very early stages of that, but I thought I would mention it since that is something we're collaborating on. Okay, as far as the tools that we've been working on, we've got some climate tools that we've worked with Alex Ruin on. They're written in R. They were originally MATLAB, and they've been converted to R such that it's freely available for anybody to use, whether or not you have MATLAB. We've got the crop model data translation tools. We're going to be talking a lot about that today, and actually demoing those tools, and the crop modelers will be working with those. We've got web and desktop interfaces for using these modeling tools. And all of these applications that we've been developing are being developed in an open source format. We're using GitHub. You can go to github.org/agmip and take a look at what we've been working on. And if you're interested, we welcome you to join the development community and contribute to the tools. Okay, the databases that we're currently working on are the Crop Experiment and Sentinel Site database. This is operational. We'll be working with that today. We have a crop model output database that we're also going to be demoing today. That's not fully operational right now. It's in a spreadsheet type format. We're not actually archiving and storing the data. Crop scenarios. This is we talked a little bit about the dome yesterday. This is our means of taking management regimens or management scenarios which come out of the RAPs and being able to store those and apply them to your data. So you could take baseline data and modify it for future conditions. That'll be stored separately. It's not site data, it's not recorded data, but it is important that we maintain an archive of those types of data that we use in our models. And we're also trying to work with gridded data. There's groups working, there's a 10 model intercomparison of global economics, and all of them use a gridded system for biophysical modeling. So there's an awful lot of data that we want to be able to make available to the modeling community that has to do with gridded systems. Okay, this is kind of a schematic of the AgMIP data products. This is the bigger picture. What I covered in the last slide was what we're currently working on, but this is kind of the broader picture of where we need to be. Maybe not all in AgMIP 1, definitely not all in AgMIP 1, but eventually this is the full AgMIP IT big picture. So we've got harmonized databases over on the left. We've got the tool shed in the middle. We've got our AgMIP models that we work that interact with the toolshed and the databases. We've got web services, and we've got external inputs, mainly data, that we'll be dealing with. But probably the most important product that we have in our AgMIP data community is communication. Because without communication between the teams, AgMIP won't work. Okay, so a little bit more about our crop experiment database. We're calling it the ACE database, AgMIP crop experiment, which is a little bit of a misnomer because it's not just crop experiments. Sometimes it's survey data, sometimes it's variety trials. It's various levels of detail of data. If it's site-based and it's recorded from historical crop growth, this is where the data are stored. The detail and the types of data provided by the different site-based experiments is extremely varied. No two experiments are alike. Some you may have very detailed fertilizer information. Others you may know that it was fertilized, but you don't even know how much. Our database needs to be able to store all of these kinds of data. Whatever we happen to know or whatever was recorded, we want to be able to archive that and make it available. So it's a challenge. It's not very regular data. So what we've done is we've adopted the AgMIP master variable list. This is a list that has been developed by Jeff White, Tony Hunt, and others over, I don't know, 15 years or maybe more. And it is a comprehensive list of variables that describe a field experiment. Okay, so I say it's comprehensive. We've learned through AgMIP that we've had to expand it slightly, but when there isn't a variable there to describe what we need, we can add it. So that's one of the beauties of using the system. We can extend it as needed. But what we do is we use the variable names in that list to harmonize our data. So if you have crop yield, you look at what the variable name for crop yield is. If you call it that, we know what it means. We know the units, we know the definition, and we can store it and make it available. So in this way, we're able to map the different crop modeling data with these class of variables and do our data translation. We have also been collaborating with the Ag Trials folks, which is a CCAS initiative. This is a website that is maintained at CIAT in Columbia, and so we have harmonized our metadata with that, and eventually we hope to have data translators that we can go back and forth between the Ag Trials system and our own. Okay, so REAC is the database that we're using to store and archive our database, or our data within AgMIP. This is for the crop experiment data. This is a little different than your traditional what am I trying to say? Getting tongue-tied. It's in a class of NoSQL databases. It's a non-relational database. It works on a key value system of data storage. It's an open source platform, and it has been designed to work on a distributed system. It has very fast ability to read in large amounts of data and to export large amounts of data. It's a very stable operation and fairly low cost. There's a lot of advantages to this, and especially for the types of data that we're using in AgMIP, where it's not very normalized data. Every experiment is different. We need to be able to handle that flexibility, and this type of database gives us that flexibility. So just out of curiosity, how many here have used NoSQL type databases or are familiar with them? Not very many. It's a really kind of a new class of databases. So to our IT breakouts, we can talk more about that, and we can give you a little more detail about that. Okay, so this is kind of a messy diagram, but it goes through the data flow from our raw data all the way, raw data which is up on the upper left-hand side. And so it flows kind of in a U pattern down the left-hand side. At the bottom we have the crop models, and then we come back up on the right-hand side to the economic models, or the data that are ready to feed into the economic, regional economic. So we start out on the upper left-hand side with our raw data. We have each of these pinkish red boxes are user interfaces, and it shows as being separate user interfaces. In most cases, it's just one user interface that is used in various ways. So what we do is we take the raw data, we read it in to the user interface, run it through some data translation tools, store it in our database. Once it's in the database, it can be searched and queried, and we can select whatever data we want to run through the models, run it through data translation tools again, and these data translation tools down here allow us to take that harmonized data and write it out to the very specific model formats for each crop model. This is really something unique that AgMIP is doing that I haven't seen other groups doing at all. Every model, every crop model has very, very different input formats. AppSim uses XML, DSET uses text files, Salus uses Access Database, Cruxus uses Excel files. Everyone has a completely different format, but the data that they're reading in are very similar. They all take very similar inputs. So what these data translators do is produce exactly the model format that you can read into each specific model. So down at the bottom, we've got the crop models. Currently, this is all done manually. You run the crop models just as you always have, standalone. At some point in AgMIP 3 or 4 or 5, we may have this whole process in a workflow where you can select your data and punch a button and have it chug through every step, but right now this is all done manually. So we go from the crop models, we do our simulations, and we come up with the model output data. And again, all the model output data for every model are completely different. So we need to gather those together and harmonize them. And again, we have data translators that can do that step. Store the outputs in our crop model output AgMIP database, and have another user interface that the economists can use to mine that data, figure out what they need for their models, what they're going to be simulating, and it spits it out in the format that the economic models need. We aren't 100% there with all these user interface and data translation tools. We're working on it. We have data translation tools working, which you'll see today for DSET and AppSim. We don't yet have the stage where we can take those model outputs and automatically translate them into a harmonized way and put them in our database. Right now we're doing that manually, but we're working on these tools. We're getting there. That's one area where we could really use some help, and we'll talk about that in the IT breakouts. There's one other really important aspect on this diagram, and that is down in the middle, between the model input data and the model output data, you see this AgMIP simulation metadata here. And this is a file that is created as the data are being translated into model-ready format. This contains all the metadata that describes the experiment that will be simulated. So it includes information about the climate scenario, the downscaling method, the time slice that's being simulated, the particular wrap that's being simulated, the region, the strata of the region, the management ID. So it's got all these metadata The crop models have no idea what climate scenario is being simulated. They don't care. It's just data. You know, it's just reading in daily weather data. But this AgMIP file tells us all that metadata. So it follows the data through, and it becomes part of the crop model outputs database, such that we have this data provenance. And if we wanted to go back and recreate that simulation, we could do it. We have enough information to know what those outputs mean. Okay, so the crop model data translators. We have developed these over a series of development sprints, and this is typically a week-long, Steve Welch referred to them as hackathons, where we get together and a bunch of programmers sit around and create these tools. It's a lot of fun. The first one we had at ICRSAT at the last South Asia meeting. We had a second one in Gainesville last July. We had a third one in Ames, Iowa in September, and we've got the fourth one planned now for Austin, Texas in February. We're just now recruiting. We haven't actually sent out invitations yet for that. So if you're interested and if you have a model that you want to develop a translator for, that you're going to need for your projects, let me know. Talk to me about it, and we'll see if we can get you to Austin, Texas to make that happen. So, you know, all these models listed down here at the bottom are what we have worked on so far. You can see APSIM and VSAT, we have functional translators for those sticks. We also have a functional translator for the not fully tested. The rest are in various stages of development. InfoCrop we got a start on at ICRSAT last year, or earlier this year, and we didn't get very far with that. I know that's really important for some of the groups here, so that's something I talked to Gita, that maybe she may attend the workshop in Austin, Texas, and help us help us bring that further along. Okay, the DOME. This is the data overlay for multi-model export. This allows us to take experimental data, your site-based data, and do two things. Either fill in what's missing, such that we have complete data to run the crop models with. And this is particularly important where we have survey data that, you know, we know some information, but we don't know, the data are not sufficiently complete to run crop models. And then the other way we can apply the DOME is to apply RAPs. So we've got baseline conditions that have been measured, and we've simulated those, and now we want to change the management to represent future conditions, such as increase or decrease of fertilizer rates or different cultivars or things like that. So we can do that without taking our site data and changing it. We can take the site data and just apply this DOME data on top of it. And it will allow us to perturb those historical experiments into future conditions. So right now, the way we are applying these data translation tools, and you'll see this in the next session, that's for the crop modelers and IT and climate people that will stay here and work on these tools. We have a desktop utility that we'll be using today that we can read in raw data in, we're using spreadsheet templates in our raw data. The spreadsheet templates have the ACASA variables as headers, such that our data translation tools can interpret what those data mean and make them available in the specific crop model format. So we'll be demoing that with VSAT and APSIM later today. And we'll also be applying a DOME. So we can take these survey data and fill in some missing data and go ahead and make crop model runs. Okay, this is a screenshot of our web-based data search tool. This is not even beta format yet. It's under development. This is kind of a, I can give a demo of this later today if we have time and if there's interest. But this is how we will make our ACE data available and the AgMIP, the Olympics and the crop model outputs available through a web-based search. Okay, this is a screenshot of our GitHub site. I just wanted to emphasize that all of our development tools are open source. You can contribute, you can go to the GitHub site and download these applications, the source code, improve it, add your own applications, and we would we welcome your participation. We also note the authorship. We keep a repository of who has worked on what. These go into our quarterly reports to our funding agencies, so they can see that we are producing products. These are, it's a separate category in our citations, but it is, you know, your contributions to the applications will be noted. Okay, so we're well on the way. We know pretty much where we want to be going, but there's a lot more work that needs to be done. Communication is extremely important. We've got some of the tools that help enable that between groups. And if you want to contribute, come see me, and we'll figure out a way that you can help us along the way. Okay.